going to get into logarithms. And so the reason we wanted to do this prior with the exponents, this is going to help us evaluate some logarithms. So there's going to be times we simply can't rewrite powers to solve. In this case, we must use logarithms. Therefore, you must remember that if we have our exponential y equals b to the x, it has the same equivalency as saying x is equal to log base b of y. And so notice a few things here. Here's my x and here's my x. Here's b and here's b here. And so basically what we're saying is b to the x equals y is the same statement as x equals log base b of y. So this implies that a logarithm is simply an exponent. So notice here x is my exponent. So the logarithm is equal to x. So x is an logarithm is an exponent. Since logarithms are simply exponents, we can evaluate simple logarithmic expressions using our understanding of exponents. Exponential functions and logarithmic functions are inverses of each other, and so they undo each other. So like x squared and square root, those are inverses of each other because they're going to negate each other. They're going to cancel each other out. The last thing we should know is the argument. So the argument of a logarithm, it's what's inside the logarithm. So in this case, it's y, can never be 0 and can never be negative. So we have to remember that for when we're solving, that we can't include 0 as a solution and we cannot include any negative values. All right, so now we're going to flip the page. So when you start talking about logarithms, right, when we're evaluating x equals log base b of y, the question you ask yourself is, what exponent do I raise the base to, b, to get y? So what exponent do I raise b to get y? And the answer to this question is x. And if we go back to what we were looking at before, right, x equals log base b of y has the same meaning as b to the x equals y. So what do I raise my base to get y, right, to get my argument y? Two things to remember about logarithms. If we're using base 10, you do not need to put any base in your log. You can just write log x. Again, it's just one of the standard practices that if you're using base 10, it is just log x, and that's equal to log base 10 of x. So you don't need to actually write the base 10. If you're using base e, e is the natural number or Euler's number. The notation is ln of x. So ln of x is equal to log base e of x. And again, just notational. You can pronounce this ln ln or natural log of x. All right. All right, so let's look at some examples, and then you'll have a few to try on your own. So we want to find log base 5 of 125. And so we're going to go back to what question is this asking? So when we want to evaluate log base 5 of 125, it's asking 5 to what power equals 125. That is what the logarithmic expression is asking you. So 5 to the x equals 125. So 5 to the, so x equals 3 here. Because 5 to the third equals 125. All right. And letter B here, log base 9 of 27. So this isn't a straightforward one, but I know 9 to the x equals 27. Log base 9 of 27 means 9 to what power equals 27. This is going to take us to what we did in the first video. 9 and 27 are both powers of 3. You have to recognize that. So I'm going to rewrite 9 as 3 to the 2x, and I'm going to rewrite 27 as 3 to the third. And since my bases are now the same, I'm going to set my exponents equal to each other. So x equals 3.5. Lastly, C, natural log of e to the 8th. Again, the question I'm asking here is e to what power equals my argument, which is e to the 8th. Well, what do I raise e to get e to the 8th? The answer is 8. And so this will always be the case. If you have log base b of b to the a, your answer is always a. And this is because a logarithm and its exponential are inverses of each other. So now what I would like you to do is try to evaluate these, pause the video, and see if you can get the same answer that I get. All right, so hopefully you tried those. All right, so log base 4 of 4, this will equal 1 because 4 to the first equals 4. Okay, log base 6 of 1 equals 0 because 6 to the 0 equals 1. You don't have to write this. I'm just kind of explaining the thought process. So log base 2 of 32, this means 2 to what power equals 32? 2 to the 5th power equals 32. Log base 3 of 81 means 3 to what power equals 81? 3 to the 4th power equals 81. So log base 3 of 81 is 4. Now, 5 are starting to get a little more challenging. So log base 5 of the cube root of 25. So we have to recognize that this is really the same as log base 5 of 25 to the 1/3. A radical, the nth root, is the same as a rational exponent. So this is to the 1/3. Well, I can also rewrite this as log base 5. 25 is the same as 5 squared. So 5 to the 2/3. And so my answer here is 2/3. Log base 6 of 1 over the 5th root of 36. So 1 over is going to make it negative. So I'm going to rewrite this as log base 6 of 36 to the negative 1/5. 36 is the same as 6 squared. So this is log base 6 of 36 to the negative 2/5. And, oh, sorry about that. Log base 6 of 6 to the negative 2/5. And so our answer here is negative 2/5. Log 10 cubed, so this is base 10, we don't write it. That's just 3. Log of 10,000 is 4. Right? Again, because 10 to the 4th equals 10,000. Log of 100,000 equals 5. Log of 10 to the negative 4, negative 4. Log 10, log base 10 of the cube root of 10, rewrite it using a fractional exponent, 10 to the 1/3, and so this must be 1/3. Log of 1 over the square root of 1,000 is log 1,000 to the negative 1/2. And 1,000 is the same as 10 cubed, so I can rewrite this as log 10 to the negative 3/2. And so my answer is negative 3/2. Natural log of e cubed is 3. E to what power gives you e to the 3rd? And that's just 3. Natural log of e to the negative 4 is just negative 4. Natural log of 1 over e, I'm going to rewrite that as natural log of e to the negative 1. And so e to what power gives you e to the negative 1? Negative 1. This means e to what power gives you 1, and we know anything to the 0 power gives you 1. Natural log of the 4th root of e, this is the same as natural log of e to the 1/4, and so I get 1/4. And our last one, natural log of 1 over the square root of e to the 7th, is the same as natural log of e to the negative 7/2. So I'm rewriting this using a fractional exponent. And so our answer is negative 7/2. And that's how you evaluate simple logarithms. You have to ask yourself, what am I raising the base to get y? When you read a logarithm, you're asking yourself, what exponent do I raise b to get y?